So in previous lessons we talked about enthalpy. However, we didn't specify what exactly was occurring during the reactions that resulted in that change in enthalpy. So very quickly, there are a number of different types of enthalpies that can occur. So you can have the enthalpy of vaporization, which is the change in enthalpy that's involved with the vaporization going from a liquid to a gas of a substance. There's the enthalpy of fusion, which is a solid being melted into a liquid. And there's the enthalpy of combustion, which is the enthalpy involved in a combustion reaction. However, what we're going to look at in this lesson is the enthalpy of formation. Now, the enthalpy of formation is the enthalpy change that's associated with the formation of a compound from its constituent elements. Now, there's a difference between enthalpy of formation and the standard enthalpy of formation. The standard enthalpy of formation is the enthalpy of formation of just 1 mole of product, so just 1 mole being produced, when all of the products and their reactants are in their standard states. So that means the pure form of a substance, okay, so if it's oxygen, oxygen is a gas. If it's something that typically exists as a solid, it exists as a solid, so in its pure form at 1 atmosphere and 25 degrees Celsius. And the way that we represent the standard enthalpy of formation is with a delta H, F, just like that's the enthalpy of formation. However, if you notice you have that not symbol, the little 0, the degree sign, that demonstrates that you are talking about the enthalpy, the standard enthalpy of formation. One key idea that we're going to continually revisit is the fact that the standard enthalpy of formation for elements, when they're in their most stable form, is 0 kilojoules. So for example, if you have carbon, if it's graphite, which is the most stable form of solid carbon, then its standard enthalpy of formation will be 0. If you have hydrogen gas, if you have oxygen gas, those elements are going to have a standard enthalpy of formation of 0. Once you have, for example, water, the standard enthalpy of formation of that compound no longer is 0, and that would have to be given to you. So we can use the standard enthalpies of formation of all of the different compounds that are involved in a reaction in order to calculate the enthalpy of that reaction. And all you have to do is sum the standard enthalpies of formation of the products and subtract from that the standard enthalpies of formation of the reactants, the sum of those standard enthalpies. So let's actually look at an example to make sure this makes sense. This problem asks me to calculate the standard enthalpy change of reaction. And keep in mind, I can do that by taking the sum of my standard enthalpy of formation of my products and subtracting from that the sum of my standard enthalpy of formation of my reactants. So the first thing you need to look at are these standard enthalpy of formations. These need to be in kilojoules per mole, so please correct that. And the reason why that matters is because when I'm working with these problems, I need to make sure to multiply the standard enthalpy of formation by the number of moles, or by the coefficients in front of my products and reactants. So let's actually get started. The first product I have is ethanol. So I'm going to take, because there's a coefficient in front, it's going to be 2 times the standard enthalpy of formation, which is negative 277.7 kilojoules per mole. Then to that, I'm going to add the standard enthalpy of formation of carbon dioxide. There's a coefficient of 2 in front of that, so I've got to put a 2 there, times negative 393.5 kilojoules per mole. And then from that, I need to subtract the standard enthalpy of formation of my reactant. Well, there's only one reactant here, and it's glucose, so I'm going to subtract, and it has no coefficient, negative 1,260 kilojoules, which is just positive 1,260, because I have 2 negatives. So when I actually calculate this, I find that my standard enthalpy of reaction is negative 82.4 kilojoules.